Introduction to temperature sensors, thermocouples, RTDs, and thermometer ICs. Temperature sensor types. Temperature sensors are among the most commonly used sensors. All types of equipment use temperature sensors, including computers, cars, kitchen appliances, air conditioners, and, of course, home thermostats. Thermocouples. How does a thermocouple work? Thermocouples are commonly used for measuring higher temperatures and larger temperature ranges. To summarize how thermocouples work, any conductor subjected to a thermal gradient will generate a small voltage. This phenomenon is known as the Seebeck effect. The magnitude of the generated voltage is dependent upon the type of metal. Practical applications of the Seebeck effect involve two dissimilar metals that are joined at one end and separated at the other end. The junction's temperature can be determined via the voltage between the wires at the non-junction end. Thermocouple types. There are various types of thermocouples. Certain combinations of alloys have become popular, and the desired combination is driven by variables including cost, availability, chemical properties, and stability. Different types are best suited for different applications, and they are commonly chosen based on the required temperature range and sensitivity. The figure here shows a graph of thermocouple characteristics. Resistive temperature detectors, RTDs. Resistive temperature detectors, also known as resistance thermometers, are perhaps the simplest temperature sensor to understand. RTDs are similar to thermistors in that their resistance changes with temperature. However, rather than using a special material that is sensitive to temperature changes, as with a thermistor, RTDs use a coil of wire wrapped around a core made from ceramic or glass. The RTD wire is of pure material, typically platinum, nickel, or copper, and the material has an accurate resistance-temperature relationship that is used to determine the measured temperature. Analog thermometer ICs. Instead of using a thermistor and a fixed-value resistor in a voltage divider circuit, an alternative solution would be an analog low-voltage temperature sensor, such as the TMP36 from Analog Devices. In contrast to a thermistor, this analog IC provides an almost linear output voltage. See figure below. Although these devices are extremely easy to use, they are considerably more expensive than a thermistor plus resistor combination. Digital thermometer ICs. Digital temperature devices are more complex, but they can be highly accurate. Also, they can simplify your overall design because analog to digital conversion takes place inside the thermometer IC instead of a separate device such as a microcontroller. For example, the DS18B20 from Maxim Integrated has an accuracy of plus or minus 0.5 centigrade and a temperature range of minus 55 centigrade to 125 centigrade. Also, some digital ICs can be configured to harvest energy from their data line, allowing them to be connected using just two wires.